This is Kelly Lynch. I'm a rail preservation consultant for FMW Solutions. We're here today to talk about Pennsylvania Railroad steam locomotive number 1361, otherwise known as the K4. This engine has a celebrated history, a bit of a checkered past, but it's now part of a new era in the evolution of its caretakers at the Railroaders Museum of Pennsylvania. FMW Solutions was brought on to do an initial evaluation on the condition of the K4 a few years ago to determine whether or not a restoration to operation was feasible. Joining us in this conversation is Joe DeFrancesco, Executive Director at the Railroaders Memorial Museum in Altoona, Pennsylvania, Davidson Ward, President of FMW Solutions, Wolf Fengler, Vice President of Engineering at FMW Solutions, and Matt Palermo, one of FMW's staff engineers who's been steadily working on the K4 over the last 2 years. Joe, when you speak to people that are skeptical about the project or the prospects of the K4 being restored and operating again, what do you say to them?
There's a lot of skepticism, and rightfully so, over the last 20 or 30 years of the museum's history and the management of the project and the museum's management in general. You know, before the K4 project could be completely reset in a positive and professional direction, we had to get our own house in order, and that was getting the museum in order, the organization that owns the K4. So one of the very first things we had to do was restructure the board of directors, and we did that. It's a great team. It's a great board of directors. Look at our board. Wick Moorman, retired CEO, Norfolk Southern, retired CEO, president of Amtrak. We have Bennett Levin, who's on the board. Bennett knows how to get things done and knows what all this means to the state of Pennsylvania. And his vision initially for the K4 was to travel around the state, to be a living, breathing, mobile classroom to teach students and to the general public what made Pennsylvania great, and that was its industries. And the largest industry was the railroad at one time. We had significant debt. The organization had a very, very significant loan that was related to a grant in the past. And we were very fortunate that we were able to negotiate that and get out from under it. So the museum, for the first time in decades, is debt-free. We couldn't start in on the project of the K4 with the magnitude that it is with baggage. So we had to correct course, and we did.
The K4 is an iconic machine. It's an iconic locomotive. What was it about the Pennsylvania Railroad that created these generations of ardent fans?
During the peak of the shops here in Altoona, the Pennsylvania Railroad employed over 17,000 workers. Close to 10,000 steam locomotives were built in the complexes here in Altoona. A town of 80,000 people at that time. There's a lot of pride of railroaders in general, right? But there's no pride like the people of Altoona had in what they were able to accomplish in those shops over those almost 100 years in a single town. So you figure 1, 2, 3 generations of workers would have, come up through the ranks the same as their father or grandfather did, working in the same spaces with grandkids of other workers who their grandparents did the same thing in their respective roles. So you look at the K4, its time that it spent on Horseshoe Curve, helped romanticize the legacy of those workers. And whether it was be a K4 or another steam engine, there was pride to be had in all what they had done to accomplish that. But after 1955 and 1957, when the fires were dropped, the diesels just did not have the same appeal, because obviously what that meant for the workforce in Altoona was job reduction. The K4 became that icon, that symbol of what made Altoona work and what made it buzz. What set the pace of life in the city was the steam engines and the comings and the goings and the whistles and the sound of feet walking in earnest effort of the loyalty and dedication that each worker brought to the shops on a daily basis. So the locomotive now stands a chance of returning to what it was created to do, and that is to operate. However, there's just much more meaning, and that's why we've adapted, the name, the spirit of Altoona, because that is the spirit of what made Altoona great, and we want to see that done. So it's not just another steam engine for us. It's a living, breathing memorial to the railroaders who made Altoona.
The K4 that was at the museum when FMW arrived was not the same K4 that Juniata shops had turned out or that had left Horseshoe Curve. Like, we had to endeavor on a forensic analysis, not just to evaluate the locomotive, but to evaluate what had been done to it in the last 20, 30 years.
The very first task that we did was come to Altoona. We held up in Joe's office, the fourth floor of the Master Mechanics building, with banker box after banker box of files and paperwork. Went through every single piece of paper we could find to verify engineering, correspondence, material test reports for the materials that were used in the locomotive, different written accounts and reports. Like Joe mentioned, the restoration began in the 80s. The locomotive ran for a couple of years, and then subsequent restorations were undertaken. So we had a huge amount of material to go through, and our task initially was to figure out just what had been done with the boiler, primarily on the locomotive. What we found in those files was a letter from the Federal Railroad Administration from the mid-2000s, and the letter itself said something to the effect of, we're not confident with, in particular, the repair to the flush patch under the steam dome in the boiler cylinder. And the steam dome flush patch was a real Achilles heel as part of the restoration efforts in the 1990s and 2000s. So the FRA said in that letter, you have to go through, verify the integrity of this, and get us essentially better documentation on the repairs. So from that, working with Wolf and Shane, we developed an approach to testing, in particular, the flush patch as well as the steel materials installed in the boiler. It's very important when you restore any pressure vessel, in particular a steam locomotive, you have traceability of any materials that are installed on it. I think Wolf can talk a bit more about this, but the idea is you want to make sure you understand the composition of the alloys of the various steel materials that are installed in the boiler. So a key part of this was trying to bring in some 21st century technology to verify the composition of rivets and steel sheets installed in the boiler.
There's a number of tools available, but one of the factors that helped us is working with a qualified and experienced non-destructive testing company. And so they have equipment that can literally, portable equipment, literally go in and it's basically a laser device. You point it at the metal. It blasts out just a tiny little bit of that metal and it sniffs it essentially. And from that, it will tell you the alloying elements that went into that particular piece of metal. And the portability was important because, as Davidson mentioned, we had to look at rivets which went into the boiler, some of which we found were of improper materials, which would, if they'd have remained in the boiler, would have led to cracking issues. But it also allows us to verify that some of the materials that were put in, like sheets and things, matched up with the material test reports that were in the files. That was part of the forensic work that was done. And then from that, knowing exactly what materials we had available, we could start doing the calculations to see what the vessel was qualified to do from a pressure perspective.
I would point out one thing that we made sure to do from the get-go is to bring in the Federal Railroad Administration. The museum and FMW were reached out to DC essentially as soon as we started doing this investigation to say, here's the correspondence we have. Are there any newer letters? Here's what we're trying to do. We had a letter from a non-destructive testing company in the mid-2000s that had said that they had gone through and x-rayed the welds of this dome flush patch and everything had checked out okay. The actual copy of the films from the x-ray had degraded such that we thought it's probably worth our while to go through and re-x-ray these welds just to get one final set of assurance. So we brought out a non-destructive testing company to x-ray the welds in the flush patch. We did find some areas of inclusions, again, for the second or third time in these repairs. And the very first bit of boiler repair we did to that locomotive was taking out the inclusions, welding it up, to our proper procedure and having that tested. So that was the very first part of the boiler restoration, was fixing the flush patch for the, I think, third time.
One of the things that the forensics indicated as we went through the historic papers is, it's long been rumored to this, by the way, that when the Pennsylvania Railroad designed these locomotives, the cylindrical part, the boiler barrel, and the transition into the firebox was designed very robustly. That was designed to be basically a permanent part of the locomotive. The fireboxes were designed to be replaceable, and there's actually records that we found, I believe, from 1945, where they indeed replaced the entire firebox. Would make sense being in the World War II era, given the amount of use the locomotive would have had. But that was indeed the intent from the way we saw in the records and from the dimensions on the materials used. Some of the dimensions were specified at the 32nd level for sheet thicknesses. So they were really running things kind of right on the edge, and that's obviously not something that's acceptable under current FRA regulations. So we had to go through and look at the engineering of things like staybolt sizes, staybolt spacing, thicknesses of sheets, and make some changes there to make sure that part of the boiler itself was up to current code and would be safe and suitable for service for a long time to come. Because it's not just, we don't have the resources to change a firebox every 5 years or something like the Pennsy would have done. So we have to make sure that it's gonna hold up.
We have a presence on site almost every week doing a little bit of work. We're working very closely with the museum and their volunteers, and then as larger milestones are achieved, we'll schedule bringing larger workforces out to complete major repairs. We're currently working on roughing in the inside of the firebox. We've got components being heat treated right now, the back head and the throat sheet for reinstallation. And so when those components come in, we'll have a larger work session to blitz their installation. There's sort of a multi-phase approach to the engineering process, and I'll let Matt talk about this in detail, but our very first step was the forensics, determining and completing the Form 4 calculation of what the minimum thicknesses need to be and the staybolt spacing and staybolt diameters have to be. And then there's taking those guardrails, if you will, and translating those into revised drawings. And those revised drawings have to be very accurate to go against, to integrate with what's there in the field. We have, through the museum, a series of really good drawings of the boiler as it was built in 1918. They were modified in 1923, and then, as Wolf said, it got a couple new fireboxes, and all these things changed. And so you can take a drawing from the 1920s and go, awesome, we have this documentation. Then you go out there and start measuring, and there's 25 years of restoration that's modified things. But having the ability to 3D model, stress test, as well as do some of the fit-ups in 3 dimensions through Matt's work has been a huge aid to us in properly dimensioning and sourcing materials. But Matt, do you want to put a finer point on that?
Yeah, that's part of the issue with restoring a locomotive with a replaceable firebox like the K4, is that the drawings that we have to work off of were originally produced in 1918. That was before the locomotive was stoked for fire, before there was further advancements in the metallurgy field. And also when the locomotive was made, a lot of these components, like for example the wrapper roof, probably the back head and the door sheet as well, they were stamped with a die that was in the Altoona shops. They rather than being hand flanged, like they would have been actually during the original restoration in the 80s. And so over time, as the Altoona shops was pumping out thousands and thousands of these sheets and fireboxes, because remember, it's the same boiler as the L1 282 Locomotives, as well as 500 or so sister K4 engines. That's thousands of pieces, thousands of fireboxes, and the dies, they wear over time, they wear unevenly. So maybe if on the original drawing, if it calls for say a 7-inch radius somewhere, maybe over time that's worn down to a 6 7/8 radius. So trying to make sure that what we are looking at is, and comparing that to the drawing so that we know, all right, so this has changed, but this dimension here, let's say the width of the mud frame, of the mud ring, that's still the same. So how do we make sure that we are marrying these two different dimensions together to produce a firebox that's actually going to last quite a number of years and be in operation for at least 15 and hopefully for another 100 years.
We have to use modern equipment that isn't a big press with a die to fabricate replacements. Matt didn't mention it, but he spent a lot of time double, triple checking measurements, working with the fabricators to make sure they had the information they needed to actually, form sheets in certain cases, and similar things, just to make sure that fit up was as accurate as possible before going into the field. And that doesn't, even with all that doesn't always guarantee an exact fit, because sometimes there are little things here and there that are, you can't measure every inch of what you're trying to mate to, and so there's always that Boilermaker's art when you're fitting up pieces in the fabrication.
You also have to add in the extra layer of, instead of creating riveted seams like it was originally, we're now creating welded seams for between all the boiler plates. So you have to factor in, okay, well, is this weld kind of replicating that strength? Is it a little bit stronger because of the extra unstayed material that normally would have been thicker with the doubler and tripler plates in this one specific area? It's complicated sometimes.
I would say too that a Belpaire boiler in many ways is more complicated than a radially stayed firebox. What Wolf was talking about with these 32nds of an inch of thickness, Belpaire boilers or Belpaire fireboxes weigh more than radial stayed fireboxes. And I'm sure that part of the Pennsylvania's logic, in addition to just a little bit of thought about weight, was just they had 999 of these boilers. And if they can save a little bit of steel here times that many units, they were a very thrifty company. As people look in from the outside and get glimpses of the photographs of the restoration progressing, Wolf referenced the Boilermaker's art. And some of this is, there's rough fit up right now. The pieces will come back down. They'll go back up. There's inside firebox pieces. A lot of this is checking all the final geometries. So you'll see photographs of the K4 process, and you'll see there's a roof sheet on, a roof sheet off. That's all part of the process as we get all the final pieces into position for tacking, final welding, staybolt installation, all that sort of stuff. So it's as much art as it is engineering in a lot of ways.
Now that the firebox work is largely being completed, what is next from an engineering perspective on the K4?
One of the fallouts from, and I believe it was alluded to earlier, was the weight change. So we're tracking how the weight balance, if at all, is shifting on the locomotive, and that will translate into running gear work, because we have to look at any of those weight changes, if they're significant enough, if we have to rebalance the spring rigging, and then we start looking at other things in the running gear to make sure that is in good condition for operating. We noticed some wear issues in the rear truck where it was interacting with the frame, so that's something that we have to look at closely. And then just a general good look at what's going on in the running gear, and some of that's less engineering and more just the mechanical work, but our teams work very closely, as we go through some of these changes and look to see what kind of impacts they might have across the locomotive as a complete system. You can't just do things in isolation. A steam locomotive in particular, is a very integrated piece of equipment. Everything works together for that piece of equipment to work well and fulfill that ambassador role that Davidson and Joe have been talking about.
In terms of engineering, I guess just for the general public, the Belpaire-style firebox it has its drawbacks, but it also is beneficial. And this is just from an engineering standpoint, in that it makes the design formulas a lot easier, because you can just calculate everything as a flat plate here and a flat plate here within a single staybolt that's perpendicular to both plates. And that's very easy, because then you can just plug in the numbers and run with it and go, because you don't have the huge curve that you normally see with a regular state firebox, which then you have to take into account the angularity as each of the staybolts go across like that. So I know that a lot of people out there are skeptical of a Belpaire. They're like, just kind of grumble and think about, oh, well, why Pennsylvania was so stupid for doing all this Belpaire work, and they kind of joke about how, oh yeah, it was the standard railroad of the world. But there's a lot of engineering decisions that go into considerations like that. So
yeah, it's not a decision made in a vacuum whatsoever.
Exactly. Yeah.
One thing that I'd like to mention, people say, well, did the Pennsylvania Railroad do it wrong to begin with? And it's sort of I won't say they did, because I don't want the hate mail, but I would say that the railroads, the Pennsylvania Railroad had 1,000 of these, plus or minus 999 these locomotives with these boilers floating around. And my understanding is that in 1916, when the first one of these rolled off the assembly line, the factor of safety for a boiler was 3.75. In the 1920s, the ICC changed the factor of safety to 4. And if we look at the original spec cards and the original boiler cert cards from the Pennsylvania Railroad, which Joe had in the archives, we can see that they specified a 4 1/8 inch spacing on the bolts along the roof sheet and the crown sheet. Now, what happens in reality is that sheet is trapezoidal. So they're 4 1/8 inch apart at the back, and they're 5 1/8 inch apart at the front. So the math works great for 4 1/8 inch, and about a third of the way up the roof sheet, the math doesn't calc out anymore. And nobody from the ICC or the FRA back in 1940 took the calipers that Matt was talking about and checked them. They just, yeah, sure, cool. The paperwork checks out, that's fine. So Wolf, wasn't it, if we ran the numbers, wasn't it like 4.00001 or something? It was very close, wasn't it?
Well, well, really the point you made about the trapezoidal layout was key. And there's some very subtle differences between the paperwork that was filed back then. If you look at the older paperwork, the form that fills out says, the hard typed part of it says average staybolt spacing. And then there's a blank and you fill in the number, right? Well, if you look at that average number, everything's okay. But current code says that every part of that boiler has to have a safety factor of 4. And that's where you get to that front third of the firebox, and you look at the spacing there, and it doesn't meet the requirements because of that spread. It's supporting too much area, and the stress exceeds the limit on the staybolt. And so that's why we had to upsize it, and in some cases shift the bolt pattern around just a little bit to make it appropriate to modern standards. The other things we've looked at too is, back in the day, these things were hot most of the time. And when they were down for a boiler wash or whatever, they'd get refilled with house steam or hot water off of the house boiler, and they're back out on the road. Now, even in the best scenarios in a modern tourist operation, that engine may get fired up over the weekend, be cold for a couple of weeks, and then get fired up again. And every hot cold cycle puts stress on the boiler. And so we've added some additional flexible staybolts in known areas of the firebox where cracking tends to occur, and that will give the box a little more opportunity to move and a little less chance of having issues in the context of modern operations. And so that's the kind of thinking that we're putting into this to make sure that the investment that goes in now, to Matt's point earlier, is going to keep this going for hopefully the next 100 years.
The Belpaire boiler, being square, has some features that a normal radial stayed boiler wouldn't have. And so if you look at the firebox from, say you're standing in the boiler barrel looking at the back head, you've got vertical stay bolts like Matt had talked about. You've got 2 rows of cross stays between the vertical Belpaire sheets. And then you have to find a place to put the back head brace brackets. So above where the stay bolts are on the back head, there are brackets that go up. Traditionally, those just go straight into the top of the wrapper sheet on a radially stayed boiler. We can't do that because there's always other stays everywhere. And so the Pennsylvania Railroad designed a brace bracket, and it's this bracket that takes 2 rows of braces, and it comes all the way from the back head across the top of the firebox. And when we were doing our initial visual inspection of the locomotive, Shane in particular looked at those and said, that doesn't look like it's strong enough to meet the standards. And so, Wolf, can you talk a bit about the finite element analysis we did and what our findings were of those unique features?
As Davidson was saying, normally those backhead braces come in at a fairly shallow angle and rivet or weld into the boiler barrel proper, and that's a nice way to get the stress distributed in a really strong element, the barrel of the boiler. But with that crisscrossing network of stays, these brackets Davidson's talking about stick way down into the boiler, and so that puts a tremendous torque arm to get that stress into the same boiler shell area. And so, we were doing the inspections and we flagged that because it was so unusual. So we modeled that up in our CAD software and did some finite element analysis work on it. And sure enough, the stress that we were seeing, from that torque going into the rivets that were attaching that to the boiler shell proper, there were some hot spots showing up. And so that's part of the work that we're doing as the boiler goes back together, is those parts have been redesigned and will be installed as weldments to get that stress nice and smoothly. Matt and I like to talk about flow when you're dealing with stress. We want to flow that stress nice and smoothly back into that cylindrical shell of the boiler that can handle that load. So
it was a factor of safety of like 2 on the original brackets the Pennsylvania Railroad did. So we've redesigned it, and they're not that different, but just thicker metals in a different shape. And when you look at the boiler design itself, the cylindrical course that the steam dome is it's like the hardest working course in the boiler. It's got the dome, it's got the transition to the Belpaire sheet, it's got all the terminations for these rods. It's pretty unbelievable how much stuff is going on in that one course of the boiler.
I was just going to mention that the backhead brace brackets are also on that flush patch with the dome that we needed to have inspected and repaired. So, it's not just for the dome. There's also other engineering things around it that help keep the boiler safe. So.
Well, if you can, let's compare locomotives to aircraft, right? We have a factor of safety of 4 that we have to deal with on steam locomotive boilers. When you go to something like an aircraft, you're looking more like a factor of safety of 2.
Joe, how are you feeling now that the firebox, the heart of the locomotive, is being addressed in this manner? How are you feeling about the next phases of this project, the running gear, et cetera? Like, what is next once the firebox is wrapped up, and what do you hope to see in the next year?
Visually, we'd like to see the boiler back on the frame. I think that would be a very exciting next step after the firebox is complete. So in terms of details, we want to work with your mechanical department to outline what's what steps have to happen next. Is it running gear work? Is it frame work? Is it a little bit more boiler work? Whatever it takes to appropriately get it ready to receive the boiler again. We'd like to see that done. And from that will outline the next phase of fundraising for the match the next phase of the project, because people feedback we get besides where's it going to run and when it's going to run is people literally walk into the shop space on a tour and they ask the tour guide, where's the K4? They can't recognize the locomotive in their midst, and just because of all the parts, it's everywhere. We tell everyone it's all around you right now at the moment. It's spiritual form. No, but in all seriousness, I think the next step should be, in terms of fundraising, raising funds to get it back on the frame, because I think that will knock out a few other items too on the checklist of items to be complete. So that will hopefully motivate the base, motivate our supporters, and get people excited, because I tell you, the idea of a boiler back on the frame is very exciting and appealing to even me personally, because that's probably one of the most significant steps we can take to show really big progress.
So, Joe, I can't think of a better location to be restoring the K4 other than Altoona. It really is the home for not just the K4, but for the designs and ingenuity of the Pennsylvania Railroad. The museum there is one of my favorite railroad museums in the country. It's so artfully designed. It does such a great job of bringing Altoona to life, and I hope the K4 will be a beautiful complement to the museum once it's operational. You can learn more about the museum at railroadcity.org, and FMW will be releasing excerpts from our initial inspections and our findings from 2019 so that people can understand a little bit better this forensic analysis and this approach we took to start the project, and that is now carrying us through the majority of the firebox work and will continue to carry us forward through the restoration of the locomotive. Gentlemen, thanks for getting together today to talk about the K4, the spirit of Altoona. If you want to learn more about this project, visit FMW Solutions or click the link in the description.